Okay, finally, today we're going to talk about Newton Beta's method motion of equations and how we're going to solve the structure's response under earthquake and how to calculate it. Uh, Firstly, what we're going to try to solve here is calculate the response structure under earthquake numerically in this lecture as the first assignment of yours, second assignment for you. So we're going to introduce this very basic. As we all know, the second Newton's rule is decide that the acceleration that generated by the unbalanced external force and is relational to the mass of the objects. Also, Hooke's law told us that the spring's deformation will generate a spring force, with ratio force is deformation, okay, for spring. So actually, the structural dynamic problem is combined these two laws together. Consider that we have a mass, which is structure's mass, and with spring, and which is structural deformation, like column or like the pier of the bridge, and an earthquake. The spring will move, and they also have the mass to take the acceleration inertial force. So as the balance of Newton force and Hooke's force, as you can see, show in this equation, we consider that once there is unbalanced force, for example, like structural inner deformation, then there will be generate some acceleration. On the contrary, if there's acceleration generated for structure, so the structure will deformate and there will be spring force generated. This is the first thing we're going to talk about, the equation of motion, okay, the Newton's force and the Hooke's force. Actually, both Newton's rule and Hooke's rule is correct. However, when they acting to the structure at the same time, then the generation of the motion equations happens. And another thing is we can talk about the relationship of acceleration and deformation. As we know that the displacement and velocity and acceleration, they are related together. They just a different value by differential of time. The velocity basically is a differential accumulation of the acceleration. Displacement is accumulation of velocity. And so the acceleration will be the 2 times of, here x is the displacement, time differential of displacement, it will becomes acceleration. So this is basic about velocity, displacement, and acceleration. As you already know that in high school. What is more we need to explain today about the structure's response and ground motion is this very simple model. You can see that this part is the mass and spring that we explained, which is representative of the structure. And this cart, the movable cart, is all ground. And this fixed part, we can see that this is our planet. This is Earth. And we consider that the ground will shake, will move due to the cracks of our Earth, of our plate. And when the foot moves, and the ground will shake, and our structure is built on the surface of the ground. So when ground moves, there will be vibration generated in the structure model. So this is a basic explanation of what's the meaning of this model. Once the ground moves like this, because inertial force happens, structure will tilt it to the other opposite direction. And we see the relative deformation of structure themselves is x, and the movement of the ground is y, and the absolute movement of x will be z, which equals to y divide x. So its roots also can be seen as the ground acceleration will be y's second time of time difference, and the structure's relative acceleration, it will be 2 times of x. Thus, the global acceleration that acting on the small mass, on the mass m, will be z, which is the difference of ground acceleration with the relative ground relationship acceleration of the mass. Here, because the deformation of direction of the ground and structure deformation is opposite, so here's minus, or you can plus them together if you define them in the same direction. And now is the time to see the equation of motion. As we know that this side is the Newton's force, and this side is the Hooke's force. And if we instead of our ground motion and our structure's acceleration here, we can see they can still keep the balance, because as this is the global acceleration. And we change the expression to ag and a, which ag is ground acceleration, this is structure acceleration. And they will equals to the spring force generated by the structure deformation. If you put this part of a and m to the other side of the equation, then we can rewrite the equation like this. And this is basic of equations of motion without any other force. However, in the actual world, we have damping force here, CV. And if we also considering the structure damping, then there will be total equation of motion for the ground motion problems. So maybe I need to explain a very quick explanation. What is CV?